Math 1332, Chapter 2, Set Theory, Section 2.2, Subsets and Set Operations, Video 6, Subset Examples. In the previous two videos, we've defined subset and proper subset. Now, I realized after I ended the previous video that I said I was going to do something and I didn't. And that something was how to remember which of the two symbols means subset and which one means proper subset. This one meaning subset versus this one meaning proper subset. Both of them mean that the first set is inside of the second one, but one of them says, but they can't be equal. The easiest way to remember which one says, but they can't be equal, and hence they are proper subsets, is to compare it to two similar symbols, less than or equal to versus less than. Which of these two symbols says the numbers cannot be equal? Well, the first one says they can, less than or equal to. This one is called a strict inequality. It is strictly less than. So if I said 5 is less than or equal to 5, that would be true. But if I said 5 is less than 5, that would be false because the less than sign does not allow it to be equal. Just remember, the symbol with the line underneath it means it's okay if it's equal. Without the line, it's not okay if they're equal. Same thing up here. The line underneath means it's okay if they're equal. No line, it's not okay if they're equal. So you could almost read this as subset or equal to versus proper subset. But just remember, if it's got half of an equal sign, then it's okay if the sets are equal. If it doesn't, then they can't be. That's the gimmick I use. All right, so let's take a look at 7 examples and simply determine if these statements are true or false. Starting with A. Actually, I invite you to pause the video to see if you can figure out which ones are true or false. Just remember, to be a subset means everything in the first set belongs to the second. To be a proper subset, you also ask, are you different? Or equivalently, does the second set contain something that the first one doesn't? So pause the video and see if you can determine which of these are true or false. A couple of them are tricky. Hope you paused the video. If you didn't, then I don't know what to tell you. I gave you an opportunity to try it before I do it. You should take that opportunity because on a test, you won't have somebody else's lead to follow. All right, part A, the set containing 1, 3, and 5 is a subset of the set containing 1, 3, 5, and 7. To see, check if every element of the first set belongs to the second. Excuse me, 1, do you belong to the second set? Yes, I do. 3, do you? I do too. 5, do you? Yes. And that is sufficient to say that I'm a subset. So this is true. Notice I didn't ask the second set, do you contain someone the first one doesn't? Because I wasn't asked if this is a proper subset. It is, but that's not what I was asked. Part B, the set containing X and Y is a proper subset of the set containing X and Y. Well, if you remember the definition of proper subset, this is an instant false. Because the second part of the definition says, and the sets are not equal. These are. But if you're doing it on an element by element basis, then you would do the following. Go to the first set and ask each element, do you belong to the second? Excuse me, X, do you belong to the second set? Yes, I do. Excuse me, Y, do you belong to the second set? Yes, I do. So we've established that you are a subset. But to be a proper subset, I have to go over here and ask one more question. Excuse me, larger set, do you contain anybody that isn't accounted for yet? No. Everybody was over here. Oh, this is not a proper subset because these can't be equal sets. This is false. Part C, a little bit of set builder notation. The set of x's such that x is an element of an even number, so basically x is an even number, and x is greater than or equal to 15, is a proper subset of the whole numbers. So I'm asking 2 questions. Is everything in the first set also in the second? And does the second set contain numbers that the first one doesn't? It might be easier to see if you were to list each set in roster form, but you don't have to. You may already know that this is a true statement. In roster form, the first set is all the even numbers that are also greater than or equal to 15. So they would start with 16, 18, 20, and go onwards. And we're asking if that is a proper subset of the whole numbers, which start with 0, 1, 2, 3, dot, dot, dot. Now, I could write all the way out to 20 if necessary, but I can just imagine this. To check subset, I need to check everything here. 16, are you over there? Yes. 16's over here somewhere. 18, yes. 20, yes. And everything afterwards will be there as well. But for proper, I have to follow it up with, okay, second set, do you contain anything that wasn't checked off? 0, 1, 2, 3. Every number up to 15. And then all the odd numbers after that were excluded. Plus, these sets aren't equal. This is a true statement. The first set is a proper subset of the whole numbers. Here's where you have to be a little careful. The set containing cat and dog is not a proper subset of the set containing dog and cat. When you're being asked if a subset statement is true or false, but it contains is not a subset or is not a proper subset, one way to approach it is to answer the opposite question. In other words, what would you say if this said proper subset as opposed to is not a proper subset? So we're going to answer an alternate question first. Cat, dog, proper subset, dog, cat. So is the red statement, and my apologies if you're colorblind, is the red statement true or false? Well, is it a subset? Yes. Every element of the first set belongs to the second set. But is it a proper subset? No, because the second set doesn't contain extra elements. These sets are equal. You can't be equal when you're proper subsets. The red statement is false. So if the red statement is false, guess what that means about the original statement? That it has to be true. Cat and dog is not a proper subset of dog and cat. Now you may have been able to determine that that statement was true without looking at its negation. What would it be if it said proper subset? It would be false. Therefore the opposite has to be true. But that's one way to attack the truth value of a statement involving the opposite of something. Same thing with this one. Example E. The set containing Texas and New Mexico is not a proper subset of states that border Mexico. If you're having a hard time deciding if that's true or false, look at its negation. What would it be if it said proper subset? We'll abbreviate over here. Texas, New Mexico, proper subset. We'll just say border states for brevity. And let's determine if this statement is true or false. Is Texas and New Mexico a proper subset of border states? Is Texas among the border states with Mexico? It is. Is New Mexico among the border states of Mexico? It is. So we've got the subset criteria, but is it a proper subset? Meaning, are there border states that were not included over here? And if you're not sure, you can list them out. And if you're not familiar with American geography, Texas, New Mexico, Arizona, and California are the border states with Mexico. So we would have checked off the first two. But when I asked the larger set, are there elements that weren't checked off? Yes, there were two of them, Arizona and California. These sets are not equal. Therefore, this set is a proper subset of the border states. That statement is true. So if that statement is true, that means its negation was false. Saying this is not a proper subset of that is a lie, because it is. Example F. This one's tricky. The set containing the word red is a subset of the set containing the letters R, E, and D. It brings up the question, is this one word or is it three letters? In the context of a set, elements are separated by commas. commas separating anything in here. Relative to this first set, this is one element, the word red. So to answer the question, are you a subset, I have to go to this set and ask each of its elements, it only has one, red, are you an element over here? And the answer is no. The letters that spell red are over there, but the elements of this set are the letter R, which by itself is not the word red, the letter E, which again is not the word red, and the letter D, which again is not the word red. So this element is not an element over there. You have to be in order to be a subset. This statement is false. And it wasn't because it was a proper versus not. It was an issue of this element is not over there. You have to learn to look at things as elements and not, oh, these are the letters that spell this word. So that was a tricky one. And the last example, G. The set containing 0 is a subset of the empty set. Well, let's check it. Go to the first set and check, ask its elements, do you belong to the second set? 0, do you belong to the empty set? Nobody belongs to the empty set. This is false. Any non-empty set will never be a subset of the empty set. In fact, the empty set only has one subset, itself. And the empty set has no proper subsets. Chew on that for a while. So when you're being asked, is a subset statement true or false, be it subset or proper subset, you can check it at the element level by asking every element of the first set, do you belong to the second one? If their answers are all yes, then you are a subset. And if there's an element in the second set that wasn't in the first set, then you can say a stronger statement that it was a proper subset.